All right, we're back. This is Techmath1. We're looking at 7-10 number 87, and we're finding the surface areas. Now, surface areas. And so when we look at surface areas, that's like if you covered the outside entirely. If you covered the top, the bottom, and around. And so when you have a cylinder, think about like a soup can. If you peel the label off a soup can, you get a rectangle. But then we also want the circle on the top and the circle on the bottom, right? Here, we'll put the other one up there. Kind of ran out of room for the circle. All right, so the surface area would be this area plus this area plus this area. And if we think about how to find all of these, let's see what they give us. They give us the radius is 3 inches. And they give us the height is 12 inches. So this is pretty easy to find because that's just 12 inches. That's just that height right there. That's the label, right? But the length on this one is a little harder. You got to really use the old brain on that one. It's around the circle, right? Like the circumference, that's circumference. So remember, circumference is pi times diameter, or pi times 2 pi r. Like 2r is the same as diameter. So you could replace d with 2r because 2 radiuses is always going to be the diameter. So when we want to find this length, it's actually going to be 2 times pi times 3. And we can put in an approximation for that. Now, depending on how much precision, right? Precision that the question requires. We talked about that in the past already, precision. You wouldn't round unless you know. I'm going to go with 10 thousandths place for precision. So 2 pi times 3. So I'm going to call this 18.849, and then it goes 5. So I'm going to go 96 and go out to 10 thousandths place for my precision. Okay. And then the circles, that's going to be the area of the circle is going to be pi r squared. So that's going to be pi times 30 squared. So pi times 9. So that's 28.2743. All right, and so now there's 2 of those though. So this one's 28.2743, and this one's 28.2743. And so if I add this plus this, oh, I didn't actually multiply that through 18.8496 times 12. That area is 226.1952. So we've got that area plus that area plus that area. Or if you look at their formula that's given, if you just want to do plug and chug, you could just say the area is equal to 2 pi r h plus 2 pi r squared. We just did that. Look, here was 2 pi rh, 2 pi rh. They just, you know, we did 2 pi r, and then they did h, so they got that height in there also. That's why they have an h and we don't. We found that length, then multiplied it right there. That's this calculation. So they kind of simplified it into one thing, and then 2 pi r squared. The 2 isn't there for any other reason that there's just the top and the bottom of the can. That's where the 2 came from. This is pi r squared. So you just plug in the r and the h if you want, and then do it. If it's more complicated, you know, solid, you might want to map it out like into 2 dimensions, from the 3-dimensional picture to a 2-dimensional picture, and then find each area and then add them up. So plus 2, 8, depending on what field you go into. Like I don't know if they even use AutoCAD anymore or something like it, the newest iteration, where you can do 3D modeling. The printers, right? The 3D printers, those are a big thing. No, those are pretty cool. All right, and then let's see, what round to a whole number. So they wanted, what did they want here? S, oh, 2 pi r h, so they wanted just, oh yeah, that's right. This book calls it, they gave it a name, the lateral surface area. The lateral surface area is like the label. So they said they wanted S, that's this thing, and they wanted A, the whole surface area, that's that thing. And so, oh, but they wanted it, what, to a whole number? To a whole number. So 226, S is equal to 226. And that's area, we're back to area, so that would be inches squared. And 283 inches squared. That's going to also be inches squared. It's just the area of the whole surface area. All right. Lovely, lovely. Then let's do one more. Let's do 90. That is the volume, or I'm sorry, not the volume, a surface area of a sphere. So like a perfectly round sphere. A surface area of that. So this one, unless you're a super genius, I don't think you're going to be drawing a two-dimensional version of that. That would be like peeling a orange and trying to flatten it out. And it doesn't, right? It doesn't flatten out easy. And so that would be rather hard to model as a picture. So whenever you want to draw like a sphere, you draw a regular circle as good as you can. And then to make it look three-dimensional, you kind of put a smiley face on it, like from ear to ear, and then do the dashed little line around the back. And then it, I don't know, I'm not really good at trying, as you can see, but it kind of has a 3D picture-ish, look-ish to it. And so they gave us the radius is 8.5 inches. All right, so if we know the radius is 8.5 inches, this is going to be purely just plug and chug 4 pi r squared. So the surface area of any perfect sphere is 4 pi, and we just take the radius, 8.5 squared. So it ends up just being a calculator problem. So 8.5 squared times pi times 4. And there we go, 907.92027769. And what do they want that to? Whole number. All this precision, they want a whole number, 208. And that again is going to be in square inches. That's how much wrapping paper you'd need to completely engulf a sphere. Okay. All right. Then the last one that we're going to cover is density. Density, 711. So 711 on number 92. So that's in the blue book on page 319. So to find density, you take weight and divide it by volume, and that will give you a density number. All right? So density is equal to weight divided by volume. So if you look at number 92, they give us a weight and a volume. They say, find the density of aluminum if 100 cubic centimeters of aluminum weighs 256 grams. So we put the 256 grams on the top and the 100 centimeters cubed on the bottom. And then you just divide. Pop that into your calculator, or don't, because it's 100, right? You just move the decimal 2 places. 2.56, and that will be grams per cubic centimeter. And so when you're describing density, it's sort of like a rate. It's the weight to volume rate. All right, so 2.56 grams per cubic centimeter. Let's look at 93. What do they ask about with 93? It says, how much does 33.4 cubic inches of steel weigh? I don't know. Let's see. So weight then, well, think about it here. If we have density is equal to weight times its volume, then if we want, we could multiply both sides by V and say weight is equal to D times V, right? Or V times D. Let's go with D times V. All right, so dV. Okay. So it says, since the density of steel is 0.283 pounds per cubic inch, then you just multiply the volume. So how much does 33.4 cubic inches of steel weigh? Well, we would just multiply that, and weight will equal, they gave us the density is 0.283. And if you think about this, this is pounds per cubic inch for 1 cubic inch. But then we're going to multiply that by 33.4 cubic inches. And then that's like sort of like over 1. And then those cross off and you'll just be in pounds. And that would be the weight. So you just multiply those two. It says round to hundredths. It should work out to be the 9.45 when it's rounded. All right. So just straight across, 0.283 times 33.4. And, oh, that would be in pounds. All righty. Let's jump to a harder one, like 97 is pretty tough. That is a piece of circular wire is a cylinder. The diameter of 12 gauge copper wire is 0.081 inches. The density of copper is 0.322 pounds per cubic inch. Rounding to hundredths, find the volume in cubic inches of 100 feet of 12 gauge wire. All right, so we're gonna find the volume. So you've gotta use your imagination a little bit here. And I'm gonna make an exaggerated sketch of it. Okay, so think of it as a really long copper wire that's really small. All right? And so they told us 100 feet of 12 gauge wire. Okay. So we have to find the volume is going to be the area of the base times the height. But we want the height not in feet, because when we look at everything, it's in inches. So 100 feet, we want feet to be in inches. So 12 inches in 1 foot, feet cancel, that's 1,200 inches. So that's what we want there, not that. So 1,200 inches. And then they tell us that a 12 gauge copper wire is 0.081 inches. And so that is its diameter. So we actually got to cut that in half. 0.081 divided by 2. So what is half of that? Let's find that. That would be the radius. 0.081 divided by 2 is 0.0405. 0.045. That, or no, I'm sorry. This is how we calculated the radius. They gave us the diameter by saying that's how thick it is. All right. So they gave us the diameter. They gave it all the way across the circle, but we only wanted half the radius. So the radius is that. And now how do we find the volume of anything? That's the area of the base times the height. So pi r squared times the height. So pi times 0.0405 squared is 1,200. Should be our volume. And that's going to be in cubic inches. And so what do we get? 6.18. 3, 5, 9, 6, and they only want it to hundredths. So 6.18 cubic inches would be the volume. So if we know the volume, let's see, find the weight of 100 foot 12 gauge copper wire. Well, they already told us the density is 0.322. So if we know the density, we can find the weight, right? Because weight is just equal to, we just had that on the last page, density times volume. All right. So we just found the volume, so we can put in our 6.18. And they gave us the density to be 0.322. And so we multiply those two. And we get 1.9899. And then we round to 1.99. Oh wait, what do we got here? Yeah, 1.99. So 1.99, what are we in there? Was it in pounds? Just about 2 pounds. So 100 feet of 12 gauge copper wire is going to weigh just under 2 pounds, 1.99 pounds. All right, that's it for chapter 7 out of the book. We're gonna look at the handout, just a couple of problems from the handout on E and F.